Hey folks, Mr. Dell here. We are looking at equations with fractional coefficients, right? So this is basically using fraction busters is the term in order to write an equivalent equation and then have an easier equation to solve. So a more simplified equation to solve. So I'm taking these problems this is from CPM course 3, and this is the parent guide, right, for 5.1.2 and equations with fractional coefficients. So I'm going to pick a couple problems from this parent guide, and I'm going to pick, let's do numbers 4 and 5. So I'm going to show you how to do number 4 and 5 and 6. I'll do 4, 5, and 6. Okay. So the equation here is for number 4 is negative 8/3 m equals 6, right? So, oops, that's number 4. I didn't put the number 4. Negative 8/3 m equals 6. So what we want to do is we want to be able to have an equation without fractions. So that way I can just solve and I'm not dealing with fractions in the process. So when I look at this, I think to myself, okay, so what can I multiply? Because I want it. Fraction busters is the term. I want to multiply each term by something that would make the fraction term not a fraction anymore, right? So over here, I'll just kind of do a little side thought. So 8/3 times something is going to make this into a integer, just a non-fraction, no fraction. The fraction goes away, right? That's why the whole idea of busting. So when you think about what is it, well, what makes a fraction bust is multiplying by its denominator, right? Because if I multiply by, so 8/3 times 3, and when you multiply by a whole number, you put it over 1, 3 over 1, what do you notice happens? That 3 and 3 in the numerator, 3 in the denominator, cancel out. Why is that? Because it's the same thing as saying 3 over 3, right? 3 in the numerator, 3 in the denominator really equals 1. It cancels. They cancel each other out and become 1. So that's 1, that's 1. They cancel and become a 1. So what do you get? When you do this, you get just negative 8, right? So the whole thing becomes just negative 8. So that's what I'm going to multiply by. I'm going to take this, let me rewrite it, negative 8/3 m equals 6, and I'm going to multiply each term by 3. In this case, 3 over 1. And then over here, what I do to one side of the equation, I always do the other, and I always do it to each term. So that way that equation stays balanced. So those 3's, as I said, cancel, right? They become 1. So really what we're left with is just 1 times negative 8m, which is negative 8m. So all that's left is now a negative 8. So that busted that fraction. And so what you have to do on the other side is the same thing, multiply by 3 in order to have a balanced equation. So 3 times 6 is 18. So now I've got a nice equation without fractions, so I can continue on and remember the steps of solving equations. To get that m completely alone, I'm going to divide by the coefficient. So I divide both sides by the coefficient. So that causes this now to be m. Negative 8 over negative 8 is 1m. And then 18 divided by negative 8. Well, 18 doesn't divide evenly, so I'm going to do a few things. One, I'm going to actually convert this into a mixed number. Well, first of all, I know that it's a positive divided by a negative, so my number is negative. 8 goes into 18 2 times with 2 left over, right? A remainder of 2, because that's 16. 8 times 2 is 16, so it's a remainder of 2. So you have 2 and 2 8s, negative 2 and 2 8s, which actually then that can simplify the 2 8s. So negative 2 and 1/4. So that's my m for this question. Okay. All right. So let's look at another one. That was number 4. Let's look at number 5. So number 5 is a little different, right? I've got 3x plus 1 all over 2 equals 5. So it's all of this, 3x plus 1, all of that divided by 2 equals 5. So once again, I have this divided by 2 or over 2, and I want that denominator to go away. So what is the denominator? The only denominator I have now is 2, so I'm going to multiply both sides by 2, or 2 over 1 in this case, because I'm multiplying by a fraction, and over here, multiply by 2. Okay. When I do that, the 2's cancel. 2 over 2 is 1. And then what's left is just this 3x plus 1, right? Just the numerator. The numerator is 3x plus 1. And then equals, don't forget to multiply by 2 over here, you get 10. So now I'm solving the equation, right? Now I'm on that same track as I'm solving the equation without fractions. So I want to get my x alone. So I do the opposite operations here to get x alone. So I'm going to subtract 1 to make that plus 1 become a 0. Subtract 1 from both sides. You get 3x is equal to 9. Then divide both sides by 3, because you divide by the coefficient, and you get x equals 3. Okay. Last one. I wanted to show you this one as well, because this one you've got two different fractions. So again, it's x over 3 minus x over 5 is equal to 3. I have to get rid of both the 3 and the 5. So I can't just multiply by 3, because that'll cancel this one, but not this one. I can't multiply just by 5, because it'll only cancel this one and not this one. So what is a multiple of 3 and 5? Well, 15 is. So I'm going to take each of these and multiply each of these terms by 15. So it's 15 over 1 times 3, 15 over 1 times, 15 over 1 times x over 3, 15 over 1 times x over 5, and then just 15 times 3. I multiply everything by that 15. Why did I do that? Because in the same situation, I can actually cancel, cross reduce here, right? A little side note, 15 over 3 is 5, right? 15 divided by 3 is 5. So that's why this cancels. The denominator goes away, becomes a 1, and that becomes a 5. So now I still multiply, though, 5 times x. So that term now is 5x. This one, the same thing. 15 into 5 into 15 is 3, and that's a 1, right? So 15 over 5 would be 3 over 1. So again, 3 times x. So this becomes, not plus, it's minus 3x equals 15 times 3 is 45. Okay, then keep going. 5x minus 3x is 2x is equal to 45. Divides both sides by 2. X is equal to 22 and a half. Okay, there we go.